Earth. Distance 93 million miles. The third planet from a star known as the Sun. Temperature neither too hot nor too cold for life. Atmosphere shields us from the sun's harmful rays. Water, oxygen, clouds, storms, volcanoes, soil, everything in between. The moon, a gray wasteland. No air, no water, bombarded by meteorites, forming craters. Now bears the imprints of our astronauts. We continue the flight to the universe inward, reaching the second planet from the Sun, Venus. A nightmare. Temperature 900 degrees Fahrenheit. Pressure 90 times greater than on Earth. Mostly carbon dioxide. Mercury, first planet from the Sun. Night side, freezing cold, but on the day side, hot enough to melt lead. And the Sun. Sunspots and prominences dominate the surface. Temperature of the core 27 million degrees. Our flight to the universe continues, past Earth, to the fourth planet from the Sun, the red planet, Mars. Number of moons, 2, Phobos and Deimos. A canyon stretching for 2,500 miles. The largest volcano, Olympus Mons. Close images of Mars reveal a dead, barren surface. Dry, river-like channels that may have been carved by water. Very little oxygen. Temperature, a bit comfortable at day, but freezing at night. The asteroid belt. Asteroids range from the size of dust to the size of the state of Texas. Jupiter, 5th planet from the Sun, biggest planet, number of moons, 79, temperature, cold, atmosphere, hydrogen and helium. The Great Red Spot, a hurricane that has raged for hundreds of years. The 4 Galilean moons are as follows: Io, Europa, Ganymede, and Callisto. Ganymede, the largest moon in the solar system, even larger than the planet Mercury. Io, the most volcanically active object in the solar system. Europa, under its ice, could be an ocean of strange undersea life. Callisto, the most heavily cratered object in the solar system. Saturn, 6th planet from the Sun, easily identified by its rings. This is the surface of Titan, Saturn's largest moon. Number of moons, 82. Approaching the rings, we encounter countless particles of frozen debris and ice, each a tiny moon orbiting the massive planet. One of its moons, Enceladus, is the most reflective body in the solar system. Titan, the only moon in the solar system with a visible atmosphere, composed of nitrogen. Iapetus has a black and white color. Uranus, 7th planet from the Sun. Number of moons, 27. Neptune, last planet from the Sun. Number of moons, 14. Pluto, a minor planet. Number of moons, 5. Atmosphere, nitrogen and methane. Comets. Like a planet, a comet orbits the Sun. When it approaches closer to the Sun, a tale of ice and dust forms. The green rings around the sun are the orbits of the planets in the solar system. If we can travel at the speed of light, it could take 4½ years to get to Proxima Centauri, the nearest star. Sirius, the brightest star in the night sky. Red dwarfs, like Ross 248, are smaller and cooler than the sun. There are blue giants, like Vega. When sun-like stars lose hydrogen, they grow to be red giants, like Betelgeuse. When they lose enough energy, they will collapse to form white dwarf stars. There are binary star systems. Brown dwarfs. Variable stars. Stars more massive than the sun explode in something called a supernova, forming a neutron star. The Crab Nebula, remnant of a supernova. Cat Eye Nebula, a planetary nebula. The Ring Nebula, another planetary nebula. The nebulae of Orion include the Orion and Horsehead. Nebulae are star nurseries. The Eagle Nebula, with the Pillars of the Creation. There may be planets around other stars, called exoplanets. Can any of them have life? Some neutron stars create a pulse, called pulsars. When the most massive stars collapse, they form a black hole. This black hole is a stellar mass black hole. Not even light can escape a black hole. This yellow black hole is called Sagittarius A, a supermassive black hole. Stars can be grouped into clusters. The Seven Sisters, seen here, is an open cluster. Globular clusters, like this one, are more crowded with stars. All of this that we've seen is part of a galaxy of over 100 billion stars, known as the Milky Way. Diameter 100,000 light years. Type barred spiral. The clouds of Magellan, irregular galaxies, smaller than our Milky Way. Another spiral galaxy of stars is Andromeda, a complex similar to our own Milky Way. Number of stars, 1,000 billion. This grouping of around 80 galaxies is known as the local group. There are around 2,000 billion galaxies in the part of the universe that we can see, called the visible universe. Some spiral galaxies, like Messier 81, do not have a bar and are classed as unbarred spirals. This strange-looking spiral is known as the Whirlpool Galaxy. Some galaxies are lenticular, like the Sombrero Galaxy, shown here. Galaxies sometimes collide, like the antennae galaxies. Some galaxies are elliptical galaxies, like Messier 87. Galaxies are grouped into clusters and superclusters. This computer simulation has the dots as superclusters. Quasars are the brightest thing in the entire universe. But just how big is it? The visible universe is around 93 billion light years in diameter. But how did it begin? 13.8 billion years ago. The Big Bang. After the Big Bang was a soup of particles. The particles then formed atoms, which gave rise to star and galaxy formation. The solar system then formed around 4.5 billion years ago. The floated planetary disk taking shape and planets and asteroids began to appear. A few hundred million years later, Earth began to form. Asteroids bombarded its surface, forming craters. This was the beginning of life as we know it. In 1969, Apollo 11 landed the first men ever on the moon. In 1977, the two Voyager spacecraft sent out on a tour of the outer planets. First Jupiter in 1979, Saturn in 1980 and 1981, Uranus in 1986, and Neptune in 1989. In 1981, the Space Shuttle was first launched, then retired in 2011. One of these launches took the Hubble telescope into space in 1990. But what if we look into the future? $4 billion years. The Milky Way will collide with Andromeda, forming a new galaxy called Milkdromeda. $5 billion years. The sun will expand into a red giant, superheating the Earth and making it uninhabitable for life as we know it. $8 billion years. The sun becomes a white dwarf. 1,000 billion years. As the universe continues to expand, the star formation process will eventually stop. 100,000 billion years. The universe is dead. So it's now time to be back to Earth.